simplify the expression, assume x can be any real number. We have here the radical of a polynomial. To simplify such a thing, I'd like to be able to view this as the radical of something squared. If I can do that, then I know that this radical symbol and that square almost cancel. We get to erase them, but we have to introduce some absolute value signs. So if I can find a thing, whatever thing it is, that when I square it, I get x squared plus 4x plus 4, then I can take that thing, put it between some absolute value signs, and that's going to be my answer. So let's try and factor this into two pieces that are the same. Luckily for us, we can do that because we notice that x squared is x squared, and we notice that 4 is 2 squared, and we notice that 4x is 2 times 2 times x. So this is exactly our perfect square polynomial. So I can rewrite this radical as the quantity x plus 2 squared. And then I can go ahead and apply this rule and write this as the absolute value of x plus 2. All right. If we were restricting to certain x values, if we were restricting to, say, positive x values, then I would know that x plus 2 is positive, and I wouldn't need to write down those absolute value signs. But the problem tells us that x could be any old real number. So if we used, say, x equals minus 5 plus 2 is negative 3, and these absolute values would be necessary to turn that negative 3 into a positive 3. Conversely, we could be plugging in other x values. We could plug in 17. 17 plus 2, positive 19. Absolute value of that is just 19 itself. So these absolute value signs are necessary to make sure that this quantity x plus 2 is positive, because we can sometimes make it negative, sometimes make it positive, depending on our x value.